I'm Štěpán Stenchlák, and I would like to present you with a tool that is being developed by Faculty of Mathematics and Physics at Charles University, specifically by me as I'm a PhD student here. And the tool, as you can see, is called Dataspecer, and its purpose is to help you with designing and modeling, maybe in managing data schemas and data structures in general. So maybe let's have a look at schema modeling first, because it's located in different areas in IT. First, we have some basic programming where you, for example, when you want to create some classes, you usually need to decide what fields that class will have. And that could be considered some schema modeling if the classes are, for example, too much difficult to, like, it have a lot of fields. Also, in database schemas, those you need to think how you can structurize your data, how many tables you use, and so on. So it's also a schema modeling. Then schemas in general, for example, when you have some JSON files, you want to describe them, then you need some JSON schemas or XSD files to describe those files. You have APIs where you need to describe the operations on them, the endpoints, and etc. And there are plenty of other uses of schema modeling. For example, the plain Excel table could be considered a schema because it has some columns. And if you name those columns and give them the description, then the plain table could be considered a schema. So in all of these areas, we have schema modeling. And of course, this also affects some other documents. For example, when we go back to the first point, when you design some class in programming, you need to add comments to it, maybe some general documentation. In database, besides the database schema in SQL, you may want to add some views or procedures that directly work with the columns you defined. So it depends directly on the schema you've designed. In general, you can, for example, want to have some sample data, which again directly depend on the schema. And in APIs, you may, for example, want to generate some application that work with those APIs. And there are many tools on the internet you can download that solve these individual problems. For example, the last one, the APIs, there is an Open API initiative where you basically specify or create a YAML file which defines all the operation or all the schemas, and it can they provide Open API Swagger Hub, which is an application which takes the Open API specification and creates, for example, a PHP application that can work as a REST API for your given schema. So you can easily create an application just by writing a schema. But those applications only focuses on individual scenarios. But in general, there are common issues, like when we design schemas, it's time-consuming, error-prone, and hard to maintain. Basically, you need to think of all the fields. You need to think about correct naming, and basically you can make a lot of errors, which is bad. So we want to solve it, and all of these points have those common issues. And as I said, the applications that exist try to solve it, but only in this specific area, but not in general. And besides that, there are some other better solution or advanced things. For example, you can use AI. So instead of creating the schema on your own, you can use some predictions based on your previous doing, and it can help you to write a schema. So, for example, the Open API doesn't, or the Swagger Hub doesn't have this feature that would suggest some fields or operations, which is of course pity. There could be also a mapping to a conceptual model. So, for example, any schema you can design, it could come from some conceptual model, which is basically a graph of entities and relations between them, or it could be an ontology you designed previously, and now we want to use this ontology to help you design those schemas. And again, it could be a database schema, or it could be an API. And the last point is the evolution management. So suppose you came back after 2 years and you want to change something. For example, you want to rename some field, or you want to add something. And then you would need to do, without these tools, you would need to do everything manually, everything everywhere, add the field. You may forget some places and so on. So we also want to help this or solve this problem in general by helping people to do evolution for them automatically. And as some use case, in general, we want to make very robust application that could cover all of the mentioned areas. But in general, our current use case is creating recommendations for publishing open data. So, as I said, the core of this application is the schema itself. So you somehow create that schema. I will specify it later, but it could look like this. There is a root class. It has some attributes, associations, and so on. And from that schema, you can generate many artifacts and use it in different ways. So in this scenario, and for publishing open data, we use semantic government vocabulary of the Czech Republic. It's an ontology which contains some entities from Czech laws and some recommendations how things works and relations between them. So we use that ontology to help user design that schema. So again, we still don't care how you use that schema. We only help you to build it, and then you can decide how you use the schema. So, for example, you can create XSD or JSON schema from it. So it's like a universal schema. You don't model JSON schema or XSD schema. You just model some kind of schema, and it generates all supported formats. We also can generate documentation from it, because we know that, for example, the identifier has some description. So from that, we can create an HTML file containing all the description to those entities with images and so on. So that's another thing that could be generated automatically just from the schema. We can also generate transformation scripts, because the schema is mapped to the ontology. So we could easily create scripts that takes the data and convert them to RDF. So in case of XML, we can create XSLT transformation, which takes the XML data and convert them to RDF, and then you can store them into triple store. And in case of JSON, we are able to create a JSON LD context, which again can be used to transform the JSON into the RDF. And in the future, we would like to also generate examples or some application that read those data, because we are talking about open data, so it shall be available somewhere in the internet. And therefore, it makes sense that if I design a schema, we can already, or if I design a schema, we can use it to also generate an application that can show you the data you've published that conforms those schemas. And that's one use case. I have a demonstration for it, so I will show it right now. The application looks like this. This is the main screen where you do the modeling. Currently, it's connected to the ontology of the Czech Republic, but in the future, there will be much more options. Like you can connect it to some other sources, or you don't have to if you want. But now you need to select some root entity. For example, we start with public place, which describes some interesting places in the Czech Republic or anywhere in the earth. And then by pressing plus button, we can decide what entities should be in this schema. So that can be selected from the ontology. And we can continue by selecting other entities until we decide the structure we are fine with. So basically, you can decide whether the structure of the public place would be simple, just to show, I don't know, its name and some basic identifiers, or it can be very it can have very much entities and describe basically everything you know about it. And even from that schema, we are already able to generate, for example, JSON. So this is a JSON schema you can already use to represent those data. We can create XSD schema. We can also create CSV schema. So if you want to publish your data in CSV, because we want to help the publishers to decide which format, or we want to help them by allowing them to publish in any format, so they can choose whether they want to publish in CSV or JSON. So we already are able to generate all three formats, and also we are able to generate JSON LD from it because of the mapping to ontology. We are able to generate the transformation scripts from RDF to XML, and etc. And it really depends on the user how he wants to use it. So if you are just designing a schema for your small application, you maybe want to use only the JSON schema. If you are designing an open data specification for open data, you may want to use all of it. And in the future, there will be more of it. And basically, it's up to you how you can use it. We are also able to create a documentation, which you can see here. It contains all the description, titles. As you can see, there is also an image of the model. So that and many more could be generated just from this schema, and that's our goal. If I continue, there is also another use case we want to target, and it's to help design enterprise systems with microservice architecture. So suppose you are building very large system with many services that need to communicate to each other, and they probably use some API, but also the individual services would have a database and some internal data structures, and everything could be modeled or created in our application. And usually all the naming and relations comes from the business analysis. So we expect that we would be able to read the business analysis and then help the user to create schemas for databases, for APIs, so anyone can model them. And from that, if you are modeling schema from database, you can extract it to database schema or database views. If you create schema for APIs, you can generate open API specification or test cases or anything what will be supported. It depends how many programmers we will have. But the general idea is that you just create a schema and everything that can be generated from it will be generated, and it's up to you how you will use it. Regarding the architecture, this is like the the interesting part about the architecture, and the most like the core part is the yellow rectangle where you design the schema, and it in the future it could be used directly that you generate your schema and generate some artifacts from it. So for example, you are creating very small application and you need to create an XSD schema, but you don't remember how to do it by hand, so you can create in our app the schema and generate the XSD document. But if you are creating something bigger, you can use some conceptual model which contains the predefined relations between entities and descriptions of them and so on. This can be extracted from an ontology or from enterprise architect or from UML file. Basically, anything could be as external conceptual model, and then the application help you by providing entities from that conceptual model during the modeling. And again, you can generate many artifacts from it, like documentation, schemas, application, and so on. But also we want to focus on other things, and that's the evolution in general. So if something changes in the external conceptual model, for example, you decide to rename some entities or join them, split them, anything, we will be able to detect this change because we cache the external model here in the red part, and we believe that we would be able to detect the individual changes in the model. For example, that you renamed that entity and you moved that entity, and from that the changes will be automatically propagated to the lower models, so into your schema. So the schema will be automatically updated, so you don't have to deal with if you have 10 schemas that use, for example, human name, and you decide to rename to a family name, then it will happen automatically, and from that you can generate new artifacts. But also from that changes, you would be able to generate something which is called evolution artifacts, which are basically documents that are created only from these changes. So in case of databases, it could be alter table scripts that modify your table. So if you decide to rename one field, then we would be able to generate alter table script that will change your table, and of course the new schema if you want to create the database from scratch. Also, there are specification artifacts, which are artifacts that are generated from more than one schema. That's the case of documentation. So you could have, for example, 10 different schemas for one application, and then we are able to create a documentation that contains links to all the schemas, descriptions in general, and you just need to place the file on the internet or somewhere in the shared folder, and everything is linked from the document. And also in the future, because everything is mapped between each other, in case we use some external model, for example, ontology, then we believe we would be able to create transformation between different schemas. So imagine that one schema is more general and one is more specific, but because there is a mapping between them, we shall be able to create some transformations, for example, XSD transformation that directly converts data between one and other, and so on. So it basically depends on what you decide to implement here, but our intent is to make the structure so robust that almost everything regarding the schema modeling shall be supported in this app. So that's everything from me, and of course the tool is open source, so you can look at it. And if you have any question, I would be happy to answer them. Thank you.
Okay, Štěpán, thank you for your presentation. Let's have some space for the questions. So anybody from the audience, is there anything you want to know or specify?
Okay, so I'll have a question. Just one note for the presentation, it would be great if you would show the model itself from which it was generated. This would, I think I know the model, but I think for others it would be beneficial. So this is just little note, and my question is whether you plan. So you have here conceptual model. This is some kind of generic conceptual model. I don't know what's the expressivity. So my question is, how much this is tied to SGov model itself, whether it is only this external conceptual model or it is also used somehow in this internal conceptual model graph representation. So this is one question, and the following question is: so are you going to use semantics of SGov model? So for example, some stereotypes that we are using to improve experience of user.
Okay, thank you for the question. So regarding the first question, I'm not sure exactly if I catch it correctly, but the external conceptual model is basically anything you give to the application. So it could be an ontology, it could be a UML diagram, and everything. And the red rectangle is just an internal model you cannot edit. So the application suppose that every change, or sorry, every like conceptual model you want to use must be external, and you somehow link to it.
Okay, and so maybe my question is, what is in what kind of ontology or schema? How do you represent conceptual model graph?
Yes, that's some internal representation. Currently, it's in JSON, and I think it has no specific like schema, or it's too like it's only private for the tool, and we don't publish it on the internet. If you are asking about that, so you cannot directly access it. It's only for the tool. So we don't really deal with schema of the model.
So you call it conceptual model. So I'm thinking of what expressivity it has. Is it just really relations and some kind of cardinalities over relations, and that's all?
Yes, it's basically it's a graph, and you can add some additional information to it. So if an ontology supports cardinalities, then also you can insert them into the conceptual model. But if we in the future find some more advanced ontology supporting some other kind or some other information, it would be no problem to insert it into the red conceptual model. But it's a basically graph where nodes are the entities from the real world, and the edges are relations between them.
They don't have to be entities of real world, because the external, they might come from external conceptual schema, which okay, maybe, yeah, because you call external conceptual model basically everything.
Yeah.
Which to me I have hard time to say it's conceptual model. That's only something that really resonates here. So yeah, this is just one thing that it doesn't fit me. Saying it's conceptual model and I don't know how to fix it.
I don't think that there is a problem that by conceptual model you are thinking the ontology, but it doesn't have to be an ontology.
Yes, the blue one can be basically anything who describe what describes like relations between entities. So usually it's a graph, but it doesn't have to be an ontology. It could be like literally everything from which you can extract a graph of relations.
Okay, thanks.
Thanks for clarification.
Maybe so are you most likely not going to use any semantics of SGOF itself, so somehow enhancing this conceptual model graph?
I think it could be possible in the future that we will use that information, because as I said, the red like our internal model is ready to be decorated by additional information. So if the information from the ontology really benefits the modeling itself, then I would see no problem to use it.
Okay, thanks.